Okay, now let's do question 6. Now, as you can see from there, it says the circle with center B, okay, minus 1, 1, and radius square root of 20 is shown. Now, BC is parallel to the y-axis, and CB, which means this BC is parallel to this y-axis, and then CB is 5. From here to there is 5 units. Now, the tangent to the circle at A passes through C, sorry. Now, so what we are going to do, this is the center of the circle, the one that they are talking about, right? Let's just try to draw it. Now it says this circle, right? Now they are saying the circle center, this is the center. Minus 1, 1. And then as a radius, square root of 20, and BC is parallel to the y-axis, and CB is 5. So CB from here to there is 5 units. And then AB, what is it? Square root of 20. Because AB is the radius of the circle. Okay. Now, we've just shown what they said there. But now let's look at what the question says, 6.1. Now they are saying, determine the coordinates of C. That's 6.1, isn't it? Now the coordinates of C, we are to look the x value and the y value of C. Now what we do here is this. As you can see, these lines are saying they are parallel. So which means, and this is x, this is y on the Cartesian plane. So, meaning to say, x b, alright, is equal to x c. The x that is here is the x, because this is a straight line parallel to this one, right? And then, what is xb? Minus 1. So xc is minus 1. Okay, is that clear? Now, at this point, we are also told that from here, B to C, it's 5 units. But with Y, B, if we add 5 units, what are we going to get? 6. No, what are we going to get? We are going to get Y, C. From here, if we add 5 units going up, because it's a straight line parallel to this, we are going to get this point. So now, that's YC. So now YC is YB is what? 1. So it's going to be 6. So now, the coordinates of this point is minus 1, 6. That's the coordinate of point C. Determine the coordinates of C. That's it. Done. So we can go there and then we write on C. Let me write it much more big. C is minus 1, 6. Okay. So we can erase this one. Is it clear? Okay. Now it says 6.2 now. Calculate the length of CA. Right. This line, remember they told you that the tangent to the circle, alright, the tangent to the circle passes through point C. Passes through point A. Alright, now this graph should be alright, this is a circle. So that the tangent to this circle passes through this point, alright? The tangent to this circle passes through at A and also C. This is how it should be. But what do you know about the tangent in connection with the circle. What do you know about the tangent in connection with the circle and the radius? Okay, now the tangent and the radius, what is the relationship? They are perpendicular to each other, right? So meaning to say, this line there, this line of DF, we can say DF, right? Remember, DF is the same as AC, they are gradient and everything. So line DF is perpendicular to AB. Alright? Because it's the tangent. That's the rule of a tangent. That's what it says. So always a tangent is perpendicular to the radius. So this is the radius AB, and then this is the tangent GF that is passing through this point A. Okay. Now the question is saying, calculate the length of CA. Alright. Now DF, remember, this line DF is also the same as line CF CA in terms of their gradient. Alright. So we can say line AC is also perpendicular to line AB. And what do you know about perpendicular lines? What do you know about perpendicular lines? Perpendicular lines, they meet at 90 degrees. Alright, so they meet at 90 degrees, which gives us to say this one here, this angle here is 90 degrees. So if this is 90 degrees, this line we saw know it's root 20, and this line is 5. How do we get this line? Now we use Pythagoras theorem. Alright, now the hypotenuse is given, the adjacent is given, or these two sides. According to Pythagoras theorem, the square of this side is equal to the square of that one, isn't it? So now we are going to say, let's just put AC squared plus AB squared is equal to CB squared. Alright. Now, AC squared is the one that we're looking for. AC squared is equal to CB squared minus, because it's going on the other side, AB squared. Now, what is CB squared? 5 squared minus AB squared, root of 20 squared. 25 minus 20. Is equal to 5. AC square root of 5. Some may want to just give the answer, or 2.24. So 6.3 it says there, write down the value of tan theta. You are given theta is there. Now write down the value of tan theta. Remember when they say to you write down, it's very simple. Now tan theta You know this thing, eh? Very well. So what is tan theta?
Opposite of adjacent.
Now, opposite, which one here? Because we are looking for this one. So which one is the opposite?
Square root of 5.
Hmm?
Square root of 5.
That's it. Square root of 5 all over. What is adjacent?
Square root of 20.
Square root of 20. Square root of 5 over, but the square root of 20 is 2 root 5, isn't it? Then I'm going to get half. Simple, eh? That's the value of tan theta, half. Now 6.4 says, show that the gradient of AB is minus 2. Now show that the gradient of AB is minus 2. Now, AB, remember they told you this is theta and this is theta. So tan theta is also the same as that one. Remember what is tan theta? Those are the key things that you don't need to forget. The relationship of a tangent to the radius of a circle, you don't need to forget. This thing, SOHCAHTOA, you don't need to forget. Now also, Pythagoras theorem, you don't need to forget. Now let's look at the gradient of AB. Now check theta, theta, which means this angle and this angle are the same. So now tan theta, this angle, the same. Now tan theta measures the gradient. Alright, so meaning to say that this one, the gradient of this one, what is it? Yes. So the gradient of line DF is equal to, remember GF, this gradient of this same line GF is also the gradient of DA, is also the gradient of AC, is also the gradient of AF, because it's on the same line, right? So now, gradient of, they say show the gradient of AB, show that the gradient of AB is equal to minus 2. But now, what is the relationship between AB and DF or AC? They are perpendicular. So the gradient of this one is half, okay, because of these thetas, like what we have calculated on 6.3. But now, the question wants you to calculate to show that the gradient of AB is minus 2. Now remember we said they are perpendicular. What is the relationship, or what is the relationship between the perpendicular lines when it comes to gradient? What is the gradient of perpendicular lines? Right. Gradient of perpendicular lines is the product of their gradient gives negative 1. So meaning to say the gradient of DF, when you multiply them, because remember DF is perpendicular to DF is perpendicular to A, B. So the gradient of DF times the gradient of should always give you minus 1. This is what you know. That's why I say don't need to forget this. Alright? So now from there, now what is the gradient of this? We got it already, half times gradient of AB is equal to minus 1. So now gradient, take it from there. M stands for gradient. The gradient of AB is called minus 1 times 2. So which is called minus. So now they say what is the gradient of AB? Minus 2. Sure. You're sure. Or now we can say gradient of, as you can say, is called minus 2. Then that's it done. Is it fine? Simple and clear. Alright. But don't forget these rules. Perpendicular lines, they meet at 90 degrees. Okay, and their product of their gradient is -1. Then that's done. 6.5 says, determine the coordinates of A. Now, one thing that you are very sure up to now is to get the what? Is that this line and this line, they are perpendicular. And we have calculated the gradients of these two lines. So let's use those, what we have calculated, the gradients of two lines, to get our value, right? So now, because all of them, they pass through point A. So now, gradient of AB. Let's start with gradient of AB. Gradient of AB is called what? -2. Okay. Now, what is the equation of this line AB? How do you make a line of AB? Remember the gradient is, but now it's passing. Okay, what is the equation of this line that passes through this point with this point that are given in gradient? You can make the equation of that line, right? Remember the equation of a line? Let me just write it for you. Equation of a line. You say y is called, okay, let's say y. Let me use this one because there are many, like 3 of them. So let's use y minus y1 is called m x minus. Yeah, so that's the one that we're going to use. So now, what is our using this one? Equation of this line AB. So now we say line A, B. Now it's going to be y minus, what is this point y? -1, right? Because it's point 1. It's called m. What is m?
-2.
And then x minus -1 gives you plus, because it's -1. That's it. So it's gonna be y -1 is called -2x minus 2. So y is called, we take 1 there, it's gonna be positive, -2x minus 1. We're done with this equation. Alright? This is it. This is the equation of this one. Now, let's look at line, the equation of line DF. Line DF. But now it's passing through point C. But we know already gradient is passing through point C. So we can make the equation of that line, right? So y minus 6, using this same equation, right? Y minus 6 is equal to half. Okay. X minus
6.
Okay, so what are we going to get there? Y minus 6 is equal to half x plus half, right? So y is equal to what? Half x plus 6 plus half, 7/2, right? So now we've got these two equations. So now what are we supposed to do now? We want to get those 2 points. So what are we supposed to do? Okay, look at this one. Now, what was from here to here. Of the gradient, right? But remember, I want the points of A. So what do we need to do? Now we have calculated this gradient. Alright. So now what we need to do is to calculate the points on this A. Okay, but we have seen that this line, what was it? The gradient of it is half. This one is 2. This one is perfect. But now what we need from this point, this is important, but for now it's not sufficient to answer this. Why? Because we need this point A. Okay, so the points, whatever that we need is from this point A. Okay, so now to get, let's now picture it this way. What is the value from here to there? That's what you need to calculate, right? And then we also need from here to there. Okay, so now the equation of this line df, what do we know any point on this one? X is going to be some number, and then y 0. And then what do you know about this point? Y is x is 0 and y is a number. So what is that number? That's what we need from there. Okay, so now what we're going to do here, this is the equation of the line TF, the one that we've done here. Okay, but now we need the coordinates of this point. So now what we're going to do to get the coordinates of this point, this one we've calculated the value. Let's use Pythagoras theorem, okay? So what we get from, let's say from DA, but check it properly. We have got already tan theta, right? We've already tan theta. What do we get? Half for this. And also, how about for this one? 2. Okay. So now, to get this from F or OF, that's what we need to do. And also from OD. Okay. Now, what is this? It's 90. Okay. So this one, we've done it. Now we want to find the coordinates of point A. Now look at it nicely. If we were to use these points to get there, what are we going to get? If we were to use these points, what was that equation? We got what? Of DF.
Half x plus 7.
Half x plus 7.
Is it half x?
Yes.
Okay, you said y minus 6, right?
Yes.
What did you get there?
Let's just give it to first because it's
I said y minus 6 is equal
to half. Open bracket plus x plus 1.
x plus 1.
Yes.
And then we get like y is equal to half x plus
7 over 2.
6 plus half 7.
6.5.
6 plus half, what is that?
7.5. 7 over 2.
6 plus half? Mhm.
16 over 2.
6.5.
13 over? Not 7 over 2, right?
Yeah, so it's 6.5.
6.5.
Is 13 over? 2. Yes. Now this is the line, eh? You know where I put 7, we put 7, that's why like confused, and then we're saying like 7. Okay, now this is the graph that we had now, that DF. But what is this point? How do we get this point? When y is called? When y is 0 there, what is the answer? when y is equal to 0 from this equation. Remember this equation df, right? This is line df. When y is 0, that's what we get here. So what is the answer? Okay, we just say 13/2 is equal to minus 13/2 is equal to half x. Now minus 13 is equal to x. This is the point. And then what is this point? Remember we said x is 0 and then y is something. So when x equals 0, y is what? But now we want to find these coordinates at point A. Now these ones were simple. Now we are done with this one. We can erase this one here. Now to get the point at A, we just equate these two equations and get the what? The x value and the y value. That's what we do. Okay, so now let's erase this, and then we're going to remain with this one and this one. Keep that in mind, and then we'll continue from there. Okay, so now to determine the coordinates of this, we've got like first equation we said y is equal to
Y is equal to
minus 3x plus 1.
Minus 1.
Minus 1. And the other one?
Y equals to half x plus 3/2.
Plus 13/2. Then we solve this simultaneously. So now we can just equate these two y's. So it's minus 2x minus 1 is equal to half x plus 13/2. We check the x's there. What are we going to get? X this other side will be minus 5/2, eh? Then we check 1 there. It's going to be minus what? It's going to be plus there. So 13/2 plus. What is going to be the answer?
15/2.
So what is going to be your x value? S squared minus 3, right? Yes. So this is x here minus 3. Now, how about y? Now we go and input there again. So y is equal to minus 2 minus 3 minus 1. It's called 6 minus 1. Alright, 5, isn't it? So this is point A. 6.6 says calculate the ratio of the area of triangle ABC to the area of triangle ODF. Simplify your answer. There are many ways of working out that. Okay. Now be very careful when you are working so that you won't make a mistake. Remember, if you were to make a mistake that ought 7/2, all these other things are going to be a mistake, right? So make sure you punch nicely. 6.5 is 13/2 and 7/2. Okay. So now let's do the last one, the ratio of the area of a triangle. Now, the reason why I wrote this one now is simple and quick. Now listen, area of triangle.
Is this 6.6?
Yes, 6.6. Okay.
You are wrong.
Now, 6.6 say calculate the ratio of area triangle ABC. Area of triangle ABC to the area of triangle ODF. Now, area of triangle ABC. Now look at this one. ABC. Now we have everything there. This one is got a what? 90 degrees. So what kind of a triangle is it? A right-angled triangle. So when it's a right-angled triangle, what do we use? It's very simple to use this formula. What is it? Yes, half base times height. So now, what is your base? Root 20. What is your height? Root 5. Done. So what is the answer then? It's 5. Is it 5?
Yes, please.
Okay. Now area of triangle. Now we are looking at ODF. ODF. Now triangle ODF, this big one. Remember, it's also a what? Right angle triangle. But what is this to there? From here to there? 18. That's why I wrote it here. From here to there. 18/2. Okay, so now we can also do like that. Half base times height, which is half 13 times 13/2. What is the answer? It's called 169/4. Now, now let's put it like this. When you are working, put them in this improper fraction so that you can be able to get the exact. Because if you use decimal now, you are going to round it off and all that stuff. So now it says calculate the ratio of triangle. Now this one is simple. Ratio of triangle. You can just say triangle, area of triangle, A, B, C over area of triangle ODF. Or you can do the other way, like to say this is to this. Okay. So now we are going to have triangle ABC. What is the answer? The area of it? 5. Divided by this one. That's it. So 20 over 169. Or you can say 20 is to. That's what it means. So the area of, calculate the ratio is 20:9. Is it tough one there? So make sure when you're punching the calculator, get the correct value. You can punch it twice to be 100% sure. And then, so the ratio of triangle, that's it. So we are done with everything there. So, but be careful. The length of this is minus 13. Right, the length is not 0, but it's 13/2. Okay, so just need to be careful on that, and then everything is pretty easy. So when you're attempting these questions, please note the tangent rule, perpendicular rule, and then from there, the y-intercept, x-intercept, y-intercept, x-intercept, and what is everything. Those key things, then you'll be done. Yes.
I have a question. I want to ask why don't we put negative 18 over there in the formula?
Okay, how do you get, that's a good question. Now, how do you get the area? Remember, it's base times height. So if we say negative, what is the length? We are looking at what is the length of it. We're not looking at whether it's going to take side, we say minus. We're just looking at the length. So the length is 30. But of course, when you are looking at the coordinates, you have to see whether it's on the negative or on the positive. But this one is only the length. You can work it this way. This is the most simplest one. Because they were right angle triangle. You just use half base times height. Or else we're going to work it the other way around. To say the area of the triangle, this one, you can use Remember, you can just play because they are all theta. The other one, half AB sine theta, the other one half AB sine theta. Because this one, you can calculate it now, but it's going to be a waste of time. This one you have it, this one you have it, you can calculate this one. Now this one you have it, this one you have it, this one you have it. So you can calculate using that formula. The formula of a triangle, half AB sine, you know it, sine C. And then from there, you still get the same answer. So there are three more methods to do, but this one is more straightforward and simple. Let's try with this one. Is it clear?